So this is the second installment of the Geometry Clipmaps series. And in this one, in only about like 100 and something lines of code, 160 lines of code, we've got basically the core of the mesh system for the Geometry Clipmaps here. And this is really well optimized, right? We've got about 20 to 30 draw calls, right around 100,000 primitives. This is the low spec version of this. The higher spec version is to go with the M of 64, which is kind of the more standard. This is really the engine of the Geometry Clipmaps terrain, is how these meshes are constructed. Allows us to do a lot. I alluded to it in the first video, but one of the interesting things about Geometry Clipmaps is that the reduction ratio in each successive ring in the clipmap is 2 to 1. So we go from 2 quads on this edge to just 1 quad here. But that pattern repeats as you go out further and further, and that 2 to 1 ratio continues. The 2 to 1 thing is quite important for sampling frequencies and making sure that your terrain looks consistent as you go to lower levels of detail. We're already seeing gaps. So once you get gaps between your levels of detail, we need some kind of seam mesh to close up those gaps. Right, so this foundation's in place. Kind of where are we going with the series after this? We're going to look at obviously fixing up those seams, and then the next step is to actually look at the clip map height texture, right? And there's some really cool, it's interesting kind of algorithmic things happening there as well that allow us to ultimately only update one row and column. If this guy was moving at 1 meter, right, snapping at 1 meter, so every time the player moves around, you might snap, snap, snap. One of the really interesting things is that we don't need to update the whole height map texture for this resolution, right? At this resolution in this ring, we only need to update, in this case, if we perfectly moved in the x-axis, we would only need to update 1 column of the texture. So that's kind of a really, really cool insight. And we will be able to do that on the CPU. And honestly, it'll be performant enough on the CPU to be really good at runtime. 1 row and 1 column of a 128 by 128 texture is not a big deal. We can see that subdivision level in here. It's 125 by 125. So that means there's 127. I think it means there's 127 vertices on each side, I believe. I think there's 126 quads. But we would use 128 by 128 texture. The original paper does mention that there's like an unused, it'll leave 1 row and column of the texture unused. This guy would snap maybe on 2 meters, right? And as this guy snaps around and moves around, the texture for this guy will be updated at a resolution of 128 by 128 as well. So that's kind of the beautiful thing. That's the level of detail both in the meshes, but also in the height map textures. So we will get to all that in a future video. And then I have some plans on going through the Godot compute shader example. And then we're finally gonna end the series by looking at Clipmap 3D and how they used compute shaders to actually calculate that height map information. So we don't have to do anything on the CPU. That's kind of the ideal version of a Geometry Clipmap system, is that you don't have to do any calculations on the CPU. But I think for a toy model, for our purposes, I think it will be really nice to see just a very simple implementation that works well and that's fast enough for most uses. And ultimately what we're going to get to is a production ready terrain system that you could drop in your game. And I'll probably release that as an add-on, just as a super, super lightweight terrain system. It may not have all the bells and whistles, but it will work in most cases. And in my case, like, it worked very well for Bushcraft Survival. So I want to show how we can get to that. So I'm going to plug the Patreon. There's a full video detailing exactly how I wrote all this code, how I did this whole thing. You can sign up for a 7-day trial, see if you like the content, if you find it useful. But the deep dive is on Patreon. All the project files are there, all the shaders, all that stuff is there. So I hope to see you over there. And if I don't, I will catch you in the next video.